All right, guys, so we're going to talk about multiplying with vectors today. We have done scalar multiplication so far. There are other ways you can multiply. We're going to do what's called a dot product today. They are also cross products, but we're going to focus on dot products. Biggest thing you need to remember when you're finding a dot product is that your answer is a real number, okay? It's not something with i's and j's or coordinates or ordered pairs or anything. It's just a number. It's a value that you get after you are essentially multiplying two vectors together. The way you do it, it's really pretty simple. This is said v dot w. Okay, that's the dot product of v and w. And if you look, what you're doing is multiplying the two a values or x values, multiplying the two b's or y's, and then you just add those together to get a single real number. All right? So, for example here, if I do v dot w, if you look at my vector v here is 2, -3, w is 5, 3. So I'm going to do 2 times 5 plus -3 times 3. And -9, I get 1. Pretty simple. Dot products are not hard. It is just multiplying. Okay. All right. So example B here, I'm doing w dot v. Is that going to be different than v dot w? Okay, let's think multiplication. 2 times 3. Is that different than 3 times 2? Okay, so I can go through and show you, but you're doing the same thing. It'd be 5 times 2, 3 times -3. You're still going to get 1. Okay? Order does not matter when you're multiplying. All right, you guys try C, w dot w. Sounds like I'm telling you a website, but not really. W dot w.
Do we ever need to write like units or anything, or is it just the order?
No, it's just occasionally on a word problem, like you might have to tell me the resultant is like this many miles per hour, or you know, this speed or this weight, something like that. But so I think you're saying just
So like I guess it's just because it didn't give me.
All right, guys, what'd you get for w dot w? 34, yes. Are we okay? All right. Okay, so down below, just some properties for dot products. The one we just did was the u dot v is v dot u. The order doesn't matter there. U dot u, that is just the magnitude squared. Okay. You can do u dot the quantity v dot w, and that's, you're essentially just doing like multiple dot products when you do that. You can multiply a dot product by a scalar. If you multiply a vector, or if you do a dot product with u and a vector, with 0 and a vector, you end up with 0 as your answer. Okay, so 0 dot any vector is 0, which I think is pretty simple. All right, turn the page. Okay. Don't get scared of this. There's a lot of space there because we are going to do a little bit of stuff. All right, let me explain what we need in this vector. This picture here. So if I draw in this vector right there, that guy, and it needs to be called something. Let's think about what it would be. if I'm doing the head to tail method, do you guys see that vector v plus something has to equal vector u? Like I'm looking for this something, like I don't know what to call that yet. But does that make sense to you? Head to tail, v plus another vector that equals u. Okay, that's like Oki traveling to the restaurant, right? Okay, that's what we're doing there. So what would make sense here so that if I actually add them together, I would get u? Okay, what if I just solved for the blank? Just think. There you go. So this is going to be u minus b. Okay. All right. What we have to do now is try to find the angle between our two vectors. So we have to find theta. There's a formula to do this. I'm just going to go through the proof of that formula so you have some idea where it comes from. If we get to the end of it and your mind is sort of like, it's okay, you can still use the formula. I just know some of you, it's very helpful if you see where something comes from. I'm also going to label these other sides just with little letters to make it a little bit easier. I'm going to call this one A, B, and C, just for going through the formula we're going to use here, to start with at least. Remember law of cosines. Do we remember law of cosines? Yes, okay. So looking at this picture, if I want to find theta, what would you tell me for the law of cosines? Let's start c squared equals. So in this case, cosine theta, right? Yes? Okay, perfect. We're okay with that stuff, right? That is just law of cosines like you were doing last unit. Hopefully you didn't like delete that from your brain once the test was over. Hope it's still there. Okay. That is if we're using the nice just little A, B's, and C's. We're going to go back in now and substitute with vectors. So c squared, that's just the magnitude of this side u minus v, that vector, squared. A squared, that's really magnitude of v squared. B squared, that's magnitude of u squared. Minus 2, magnitude of v, magnitude of u. Cosine theta. Okay, I know that's a lot right there. Make sure everybody has that written down and you've absorbed some of
You
it.
have to do the
Yes, because the length of this side is the magnitude of it, and that's what A represents here. Like V is the vector, magnitude of V is the length of side A. Okay, so yes, I know it's like way too many vertical lines going on there, but this just looks like, I don't know, like I'm writing a bunch of ones and L's and kind of looks like it might say love in there somewhere. I don't know, but it doesn't. So I did you first, right? No. All right, we're going to use our properties from the last page to sort of expand this a little bit. This one right here, this very first one. If I have the magnitude of the vector squared, it's the dot product of that magnitude, or of that vector with itself. Okay, so I'm just going to go through and show you how we're going to expand this a little bit and get rid of almost all of these magnitude lines. So u minus v squared, that's really telling you u minus v times u minus v, okay? It should be like the dot product in between, but you're going to understand multiplication better. All right, whereas magnitude of v squared, that is just v dot v. Magnitude of u squared is just u dot u. Now, these we have to leave the magnitude on them because they're not squared, so we can't get rid of that. All right. Are you with me? Okay. Now we gotta like do some multiplication here. So this u minus v and u minus v, are you guys okay with that being u dot u minus 2 u dot v plus v dot v? Does that make sense? Okay. Then over here I still have v dot v plus u dot u minus 2 magnitude v magnitude u cosine theta. All right. We're getting close, guys. It's about to get much prettier. Wait, make sure you're on here. Now what can we do? Yeah, subtract, and some things are going to go away, right? U dot U is gone, V dot V is gone. Then I have this. If I divide both sides by this -2 magnitude V magnitude of U, is something else going to cancel out? The -2, do you guys see that? That's going to go away from both sides. Okay. And what we're actually left with is U dot V over magnitude of V, magnitude of U equals cosine of theta. There it is. Okay. No, I'm not going to ask you to prove that on request, okay? I just want you to understand that it does come from something, okay? You learn the law of cosines first so that you can figure out the angle between two vectors. Okay. All right. Wait a minute here.
Normally it would give you like numbers, right?
Yes, you're going to have like what these vectors are. Yeah. Yeah, that's just where the formula comes from. All right, anybody need more time on this one? I'm sorry. Okay, let's turn the page. So now we get to go ahead and use that formula. So we're going to find the angle between our two vectors here. We've got u is -3i plus j. And guys, I always just kind of go back and write it in component form because it's just simpler to me to just see the numbers and not the i's and the j's. All right, I want you guys to try this. And go ahead and go all the way to like evaluating what the angle is. You're going to need a calculator for that. And let's do, we'll do nearest 10th for this angle, okay? expect you to go from here to here? We just leave it like here. No problem.
You're right.
What do you mean?
Okay,
I just think the square root of
Yeah. Yeah.
Square root of this square is
Yeah. So nearest 10, yeah.
What? Yeah.
There's one in here.
The what?
Okay.
By nearest tenth, is that a decimal or is that like
One number after the decimal.
so far?
Erica, am I behind the point?
I remember it said somewhere.
What is this?
Let me show you the.
We get some points every time we raise our hand.
Send me your
Okay.
And like,
Sure. Are you sure that you want five?
she calls them. So I raise my hand all the time, but she doesn't call them.
It's not even flat.
And then there's two, she calls them like every time. Automatically gets an A for participation because
All right, let's go through it, guys. So when we're finding our angle here, you've got your formula. It's the dot product between the two vectors. So -3 times 5 plus 1 times 2 over magnitude of the first, which did you get square root of 10 for that? And then times, what, square root of 29? Okay, so that's really -13 over root 290. Okay. Then what do you use on your calculator to actually find an angle? Inverse cosine, yes. And hopefully you got 139.8.
Oh, 10.
10, yeah.
Is the quiz going to be calculator and non-calculator sections or all one?
I believe it's all non-calculator. I will check for you.
It's all non-calculated?
So like here, you'd be like inverse cosine of this and just stuff.
Oh, okay.
Yeah, you just wouldn't. I wouldn't expect you to give me
Yeah.
that. No, guys. That would be madness. Yeah. Oh. I know the looks on your faces. I'm like, why is this? No, I will not make you do that final answer to that calculator. Okay. All right. The word problem. This is not that bad. Don't get scared. There are words, you can do it. All right, so we have a plane. It is flying at 500 miles per hour, due south. What does due south mean? Yes, down, straight south. So I'm going to call this north. So due south would be like that, okay? And since that's down, I'm going to write -500, like just to remind you that it's going down, okay? The length of it, the magnitude is just 500, but the direction it's going is down 500, okay? All right. So let's real quick make the component form of that. We'll call that vector A for vector airplane. So what would you tell me is the component form of that guy? In other words, if you had to put an ordered pair at the end of that vector, what would it be? 0, -500. Good. All right. I'm going to switch colors for our wind. Okay. Then we find out we have some wind. The jet stream is 80 miles an hour in a northeasterly direction. What does northeasterly mean? Okay, like what sort of angle? If it's perfectly diagonal. Okay, good. So I am thinking about it's going to be shorter than the first vector, right? Because it's only 80 miles an hour. I'm going to call this vector wind. And I know that it's 45 degrees, like it's perfect then. Now think about what this vector is actually doing. It's not like the wind blows at this one little point and that's it, okay? The wind is pushing all the time the plane is flying. So what is actually going to happen to the plane? Yeah, it's going to go that way a little bit, right? And probably slow it down, right? Because it's getting pushed almost, half sideways, half up. Does that make sense? So we want to use what we know about vector addition, displacement, all of that to figure out where the vector for the plane ends up. So what I'm going to do is the head to tail method. I'm going to take this little green vector and move it down here. So I realize I can drag things up here and you cannot, but we'll move it down there. I'm actually going to move my label of it to the other side. So that's 80, and that's vector wind. Okay, how we doing so far? Okay, good, good. Yes.
Okay, because I think one of them works with a full arrow and a
It's weird. In some textbooks, sometimes put full arrows in. There is no consistency with notation of vectors. It's very frustrating. So anyway, it says northeasterly, so that's perfectly splitting that quadrant in half. If it said north 30 degrees east, that's going to be different than northeastern. Just like due south, we know means perfectly straight south. Okay. Yep. Yeah. Okay. Let's think about component form of this vector. So back when I had it up here, and I know I just drew that a lot bigger than I initially did, but that's so you could see it. So this was 80, and this was 45 degrees in there. What are the x component and the y component, or the horizontal and the vertical components going to be of that vector?
45, 90 triangle.
It is a 45, 45, 90 triangle.
86 and 2.
Okay, which is really
80 divided 40 root 2.
yes. Both sides are going to be 40 root 2. And guys, last class we had a whole formula that was remember when we did throwing the baseball and you had the speed of the baseball and then, I don't know what the speed was. And then it was sine of theta, cosine theta, then sine of theta. You guys remember this? It's fine if you don't, that's where it comes from. But just use what you know about special right triangles to think about it too, okay? It's going to be an angle that you know how to figure out the missing sides of the triangle from. Like it's going to be something that's a special angle. So, do we agree that the component form of the wind is 40 root 2, 40 root 2? We okay with that? Okay. On your quest, guys, probably going to be an airplane problem on there. The thing that people screw up is you mess up your signs. So that, we knew northeastern meant in the first quadrant, it makes sense that both pieces here are positive, right? What if it had been southwesternly? They'd both be negative, right? So just look at where, if I go from the origin, which quadrant would that vector be in, and make sure your signs make sense. Okay, same with the plane, like, don't lose this negative, because that means it's not going south. That would mean it's going north. So just be very, very careful with your signs. Double check those. Okay, now let's figure out where the plane actually is. So I'm going to do that guy. I'm going to call that vector resultant, because that's like where the plane ends up. Okay, it's been pushed off course a little. It's a little shorter vector because it's slowed down a little bit because of the wind, right? Okay. Think if the wind had been pushing in the opposite direction. If it had been going this direction, the plane would be flying faster, right? Okay, it'd be pushed off course in the other way, but it would actually speed up. So just think about those things when you're doing these problems. All right, if I want this vector, the component form, do you guys see the head to tail happening here? Okay, so what do I do with the blue vector and the green vector to get the red vector? Add, yes. So add them up. I don't know where you said it back there, but Gwen said add. So 0 plus 40 root 2 is 40 root 2. And negative 500 plus 40 root 2, I'm just going to write 40 root 2 minus 500. If it's a non-calculator section, like that's how you add those, right? You can't actually combine them. You might have to do that on your test. We're going to finish this one with a calculator, just so you can see like actual numbers for the speed and angle of this plane. All right. It says find the actual speed and the direction of the aircraft. Well, okay, cool. We have the component form of our plane. Does that tell me the speed and direction? No, but can I use that to find the speed and direction? Yes, what do I use to find the speed? Find the magnitudes. We got to find magnitude of this guy. So, okay. So you're doing 40 root 2 squared and then plus 40 root 2 minus 500 quantity squared. Okay. So guys, use your calculator. Please don't do this in pieces. Just key it all in, use parentheses, square root of all of that. And go ahead and give me the answer to the nearest mile per hour. But guys, I would store this answer because you're going to need it later. Okay? So. Give you a minute to find. Just nearest mile per hour. If you get a number bigger than 500, should you be concerned?
Yeah.
Yeah, because we said the plane got slowed down a bit, right? So we would expect something a little smaller than 500.
I feel like to know that you kind of have to like use common sense. But, like I don't know anything about planes. Like, not know that.
Okay, I feel like I could walk
Very-
outside with wind.
Yeah.
If you walk into the wind, it's harder to feel like progress, right?
No, you can walk like with the rules.
With the wind. It's
Yeah.
different than walking out into the wind.
Okay.
Okay, so what you need to think about, you know, imagine this is flying this direction. You know, the wind isn't pushing perfectly horizontal, but it is a little bit this way. If the wind had been going this direction, you know, think about the end of it. It's pushing it off course, but it's making it go faster. Yeah. So yes, there is definitely an element of common sense involved. Why is what straight? It's just flying straight south. It's not like, it's not dropping out of the sky. It's like elevation staying the same. It's which direction it's going. You get there? Lovely.
I really got it. The guy it's just, I was sitting here listening. I swear. I've seen this. Oh my god. I
All right, you should have gotten 447 miles per hour. All right, how many of you stored that answer? Okay, the rest of you, store it right now. Put your phones down. Store your answer. Nice of your grandma. Whatever you want to store. Okay, we're close, guys. It also says find the direction it's going. So let's look at our picture here. It is no longer going south. It is off a bit. We need to figure it out. So which angle in this little triangle do you think I want? Do I want
That one.
Okay, everyone sees that's the one I want? Okay. I need to find that angle. So, can you find an angle in between two vectors? Yes. Okay. Let's round nearest 10 this time. So, 3 to nearest 10. Do not do this in a whole bunch of steps where you're writing things down. Key it all in at once on your calculator, and you're going to need that stored value. If you use just 447, you're going to be off. So, what is good? Okay, so that is. Oh, okay. No, that's okay. You will need to do an inverse cosine of an answer here.
It's getting like way too. So it's just this plus this. So it's just according to
Well, that's what our full data set is.
Oh, yeah.
You're gonna store value.
So it's gonna be 40 root 2. No.
You don't need to do the square root of that. Yeah.
This is a 45.
I got 97.76.
You just know that the
Okay. Continue signs. Answer yet? Everyone ready? Yeah.
To find like the R. I want this
Why are you doing it? What's this? Someday you guys will win that day. Someday.
I have this, the VR, and I feel like you can make it short, but.
Sorry.
It's like, I like using this now.
And Alright guys, have lunch. Oh my goodness, you'll have to wait until after lunch. The suspense. Alright, what'd you guys get for your theta? Ooh, different answers. Should be 7.3. What? What?
What?
Okay, that went well for you guys. Yeah. Oh. 45 is the angle of. We are finding this angle right in here. Okay. So guys, key it all in at once. Please do not do little pieces. No, just do the fraction key. Your numerator is going to be negative 500 times, in parentheses, 40 root 2 minus 500.
Wait, Miss Delaney, I got 97.3. Like, I got the same thing, like, plus 90. Yeah, he was the one that I got 45, 447. It's like correct though, it's just like plus 90. Like, didn't we say like if you did it wrong, like, or was that fine? Then I'll look right here, That's fine.
Numerator would be.
Yeah.
Hi. I mean, okay.
So, not from our class.
That's it? Do the end?
Yeah, I think so.
So this, because that would be negative 500 times this.
Yeah.
That's not going to be a negative.
Oh, yeah. Wait,
It's not going to just be that if you
No, we're,
like you lost the negative 500 like times 4.
Okay.
All right, so are we? Okay, let me see what you did. Wrong one.
I used,
I got it.
wrong answer. And that
Okay, what is divided by x? Is that that's all. But this is all x. All right, who else? Troubles. Solving problems left and right here, guys.
My gosh,
So, where does that negative? Greater is zero. There's a lot like that. Okay. No. Alright. You guys got it. Alright, so we can get to Oh, wait.
I mean,
That means this.
no, probably the other way around.
Stop.
So the angle we want to find, because it started off this direction, and ended up over here, so out like you're like that. You are saying that you need to go here. You can do a log line. You're just reinforcing. Yeah, it is 45 minutes. All right, how we doing? Sid, did you get there? Yes? Better? I.
Like, how did you know that?
Why would I go from
Yeah, you told me that. I really can't. Do you know who it is yet?
Apparently she was like this girl from Loudon who was one of my friends.
Okay, I think one of my friends is friends with her. Well, I already asked you about her. You said
So the denominator where you find this?
Oh my god! Oh, yeah.
we're not that close anymore, but like she's like friends with
Claire.
your yeah, yeah.
Like that.
Okay, so she called your geography.
You see kind of who it was.
Yeah,
I'm so gullible.
That's so funny. Did she
All right, guys. The only other thing with this is how you actually write it. 7.3 degrees is lovely. Guys, up here. But I need an actual direction. So, south, north, east, west. What do you think? You said southeast.
yeah.
Okay. It's not perfectly southeast though, right? Because it's not 45 degrees. So the way you write it is, all right, south, but 7.3 degrees east. So that's saying I started south, I traveled 7.3 degrees east. Like it's the direction you were going. Make sense?
will that be like will that be how we have to like write it on our test?
Yep. Again, please pay attention to the signs, the pluses and the minuses. Please, pay attention to which two vectors you're actually using.
If you were initially going south 10 degrees east,
Mm-hmm.
then would that be 17 degrees south 17?
Yeah, if it's like 7 degrees more than the angle you started at, yeah. When I'm giving you these, one of your vectors will be nicely on an x or y axis, like something will be nice. Okay. All right, are we okay? That one was a little painful, right? All right, parallel vectors. Parallel and orthogonal, this is short. Okay, so guys, there's the sort of vector way to go about dealing with parallel vectors. I think the wordiness of it is kind of confusing. There's a non-zero scalar k such that v equals k times w. That just sounds complicated. Let's think back to what you know about slope of parallel lines from like algebra. They have the same slope, right? Okay, so let's think about these two vectors. So this v vector up here, this is 2, -3, and this one is 4, -6. How would I find the slope of this one over here, this v vector? Like, what do you think the slope of that line is? -3/2, right? We're going from 0, 0 when it's in component form. So if you're doing change in y over change in x, -3 minus 0, 3 minus 0, right? Okay. Then let's look at this one, this 4, -6. What's the slope of that going to be? Which is -3/2. So those two are parallel vectors. Okay. I think that's easier than being like, what is k? I need my scalar multiplier. Okay. So let's do this little example here. So you're given this vector v that is 3, -1, and vector u, which is 8, 12. Are they parallel? No. Why?
It's not the same.
Yeah, right away. One's negative, one's positive. You can see immediately they're not going to match. Okay? 12 over 8, which is what? 3 over 2. Definitely not equal slopes. Okay? On your quest, what a question like this will look like is I'll give you two vectors and I'll say, are they parallel, orthogonal, or neither? And I may ask you to explain why. So just make sure you can speak coherently about this in some way. You could talk about the slope of the vectors are not equal. You can talk about k if you want to. I don't think any of you are actually going to choose that, but you could. And then let's look if they're orthogonal. Orthogonal just means perpendicular. So first, if we're thinking about them being perpendicular, that means the angle between them is 90 degrees, right? And it happens when the dot product of our two vectors is equal to 0. Why is that true? Like, why would u dot v equaling 0 matter for a 90-degree angle?
It's like they're perpendicular.
I agree with that, but what does that have to do with the dot product and our, think about our formula for finding the angle between two vectors.
Because like there's no.
Cosine of 90 is 0, yes, because cosine of 90 degrees is equal to 0. And if you think about your formula, cosine theta equals u dot v over magnitude of u, magnitude of v. The only way that this works is if your numerator there is equal to 0, and that happens with cosine of 90 degrees is the angle we're looking at. Again, you're not going to have to go into all of that on this. We can go back to thinking about slopes. What do you know about slopes of perpendicular lines? What do you mean by inverse?
Negative reciprocals.
Negative reciprocals or opposite reciprocals. You guys like to throw inverse around, and I don't know that you mean what you think you mean when you say it. So let's look at the example here. So we have the vector 2, -6, and we have 9, 3. So the slope of this first one would be 6 over 2, which is -3 over 1, good. And the other one would be 3 over 9, which is 1/3. So, yes. Okay, they are orthogonal. And again, you can explain that, you know, you can talk about the dot product equaling 0. We can show it that way. I did 2 times 9 plus -6 times 3. So u dot v does equal 0. Or you can talk about the slopes are opposite reciprocals. Don't tell me the slopes are inverses, though. You will not get credit for that. Opposite reciprocal. Okay. All right. That is the end of your notes. Questions, guys? Okay. So on the actual homework that I'm grading, I'm going to have you do 2 through 24 even. Guys, you need to start looking at the extra practice and start looking at the review. Okay? Yep, even on 7-2 homework, 2 through 24 is even. If you have not looked at any of the extra practices or the review by next class, don't really expect the quest to go super great for you, okay? So, look through that stuff. We will have the first half of class to go over questions, and then the second half you will be taking the vector quest.
Do you ever think that needs grading?
Like service hour stuff?
Yeah.
It's
Okay.
like yes, but then it's
Okay. Do you think I can pass out?
like, let me look.
I don't like finiishing the notes and then